Hello everyone, welcome to the first lecture in the online certificate course on Geographic Information Systems. Okay, this is an introduction to GIS. What is GIS? What are its components? What are its main functions? And what are the questions that can be answered by a Geographic Information Systems? That is what we will be seeing in this particular lecture. So Geographic Information Systems or GIS or Geographical Information Systems are nothing but they are computer-based systems which can work with geographic data or spatial data or location-based data. Okay, so let us see how GIS has been defined by different people. So many definitions are available in different books. When we go through, we'll be getting different definitions for that. Okay, so the definitions generally refer to a GIS, or the GIS definitions generally refer to a system of computer hardware, software, and people that support the capture, management, analysis, and display of spatial data. That is very important. So you can see that any definition, if you take, it will be something like this: a system of computer hardware, software, and people, that is the whole system, then is capable of capturing, managing, analyzing, and displaying spatial data. Okay, so it is something related to spatial data, that is something particular about spatial or location based data. Spatial means it is tied to a location on the earth's surface. That is what we mean by spatial data. But in order to understand GIS better, we should break it down into its four main subsystems. That is, in order to understand that fully, so what it is beyond a computer-based hardware software system, what are the functions that a GIS fulfill? In order to understand that completely, we have to see what are the different subsystems or major subdivisions or subsystems of a geographic information system. So these are the GIS subsystems. That is the four main functions a GIS is supposed to do. Okay, so what are those? So that means the hardware, software, data, people, network, procedural system, that what we call the components of the GIS. So they should be, or that should be capable of functioning, that should be capable of fulfilling these duties or these functions. That is, input function must be there, pre-processing function should be there, analyzing should be there, output should be there. Okay, so the input function, we mean that the system should be capable of getting spatial attribute data into GIS. Here you collect and pre-process data from various sources. Okay, it is not only about scanning a map and getting into that, typing some data set and getting that as a attribute data. It is about all the input methods that we will be utilizing in GIS functions. Then we have another module as the pre-processing, or another subsystem, the pre-processing, that is for organizing data for retrieval and editing. That is, at our will, we should get it back and we should be able to do the editing. Okay, this subsystem allows you to manage, view, and edit the data sets. You might be remembering the whole system is for capturing, analyzing, retrieving, and displaying of the data. Okay, so the next module is making us capable of analyzing the data, that is, perform tasks on the data. With this subsystem, we could conduct the spatial analysis to create information. We know that processed data is information. So when you process spatial data, you'll be getting information on that spatial domain. Okay. So the output can be a map, or it can be a printout, it can be a digital map, or you can get a product that we can publish on the web also. So whatever be the output, the GIS subsystem is GIS must be capable of having that functions as well. That is, an output function should also be there in a GIS. Then only we can say that that is a GIS. That is because we consider that these four main subsystems should be there in any GIS. Another definition is equating the GIS or Geographical Information System to a spatial database. That is very important. We might have heard of the database, okay, different data sets which are holding a large number of data points, data in the information that is tied to many entities. Okay. So a system capable of working with that, we normally call that as a database management system. But here we say it is a spatial database. Okay. So you see the picture, there are two things within this. That is map or the spatial component and then the attribute component. So what does that mean? In this picture, this particular area is of a map, a cadastral map. You can think of your area. These are all cadastral areas, that is your survey numbers on which your home or your house is located, each one. Okay, so on the map, you can show it like this as land parcels. Okay, each parcel is there. But what is the attribute component? This is the map component. So attribute component is nothing but you can see each land parcel has got a particular area, an ID will be there, an owner will be there. So what are all the, I'm just giving an example. These are not the attributes given here. I'm just giving you that is suppose this is the area we are talking about. And this is where my house is situated. So the attributes are who is the owner of this particular land parcel, what is the number or the survey number of that land parcel? In which taluk, in which village it is coming? What are the boundaries? What is on the left? What is on the right? Or what is on the east, west, south, north, like that? So what are all the information other than its location on the earth surface are all attributes. Whereas the spatial data is nothing but where on earth it is situated. It is this land parcel, whatever be the attributes are attached to that, this can have only one place on their surface that is defined by this. Okay, so each point can have different coordinates, the latitude, longitude values will be there. So that will be unique for that. So in that case, we can think of a system, a computer software data people system, which is capable of handling a spatial database. A spatial database will be having two components, a map component as well as an attribute component. Okay, that is another definition, a shortest definition, that is equating GIS to a spatial database. And another definition, or we can say this is the third definition we are seeing, GIS can be defined as a tool of exploration that helps us explore geographic or spatial pattern. Okay, that is on Earth, how the Earth is. Okay, which are all the areas having a large, what you can say, some patterns, like which are all areas in Kerala which is having good amount of rainfall, which are all the areas which is having least amount of rainfall, which are all the areas which is composed of highland region where the midland is located. So that is, in that case, we should understand that spatially. Okay, on their surface we should get it. So at a minimum, it aids us in describing these patterns. Okay, at least it is helping us to show, it is helping us to describe the patterns. Just take the geography of Kerala. You can have an area, a land parcel, a land piece of land that is there on the southwest corner of India, and wherein we have a sloping area from east to west. We have the hillocks of the Sahyadri or the Western Ghats on the east, then the Midlands, which is having small hillocks, the lateritic hillock for most of the part. And then we have the coastline. So it is a sloping area from east to west. So simply describing GIS will not be just a map which is showing all this, but it can go beyond the simple description to help us investigate and understand why these patterns or this distribution, why the land is like this, and why there is a particular pattern. Say, for example, some particular rock type, particular minerals associated with that, etc. Why it is so, and the impact these patterns have on our life and land. Why it is so? What is the hydrogeology? How groundwater will be occurring in highlands, in midlands, and lowlands? How it is related to our life? So all this, and to discover potential future geographic patterns as well, where in which are all the areas where the population is increasing, and what is the geography of that particular area, and if we extract groundwater at this particular level, how far we will be able to extract water for in future. So future patterns can also be identified using a GIS. Now, So saying all this, we may feel that GIS is all about computers. Okay, only with the computers we are doing all these things, and with computers we are making maps. So and we are adding database. So we may feel that okay, GIS is something that can be done only with the computer, but it is not like that. Okay, manual GIS was also there. Okay, so why we are saying that manual GIS, that is just an example or how people have carried out works in the past, how we can consider now as manual GIS. Normally we were doing that actually because tracing the maps in different overlays and getting things done. Okay, before the advent of this computer-based one, people were doing that manually. But exactly, we cannot say that that were also GIS, but we consider that that were all manual GIS. Okay, so an excellent example of manual GIS or GIS for the first part in the history when GIS was used, or now we understand that that was geographical information actually that was in play during that time. So that was in 1840s. So the much this example, you will see that whenever we go with a GIS class or GIS lecture, we feel that, or we feel that we should tell this to the people. Okay, it is about a doctor whose name is John Snow. He is from London, and he was working with the cholera epidemic during the period of 1840s in London, in the British town of London. In 1840s, a cholera outbreak killed several hundred residents in a particular area of London called the Soho section. Okay, John Snow, Dr. John Snow was a physician, and he located the address of each fatality. That is, which he collected the addresses of all the poor people who died of cholera. Okay, and at the same time, he could identify that all these people, these addresses were clustering to, they were grouping to a particular area. That is, actually, he collected all the addresses and he started plotting that on the base map of London. And this is how this was there. Okay, Dr. John's cholera map. It was like this. And then what was his findings? On the base map, over the streets and fatalities, he drew the locations of water wells. We know that cholera is a disease which is spreading through water. Okay, so what did he do on the base map? Streets were drawn, or the roads and streets were drawn, and then the localities where, or the addresses of the poor people who died of cholera were also plotted. Then he drew the locations of water wells. Okay, from where people were collecting wells, the locations of the water wells were also plotted. Okay, then he had an idea that the idea of distance decay. Okay, that is, the distance decay is the idea that people might go a far distance to purchase a product that is cheaper. Okay, that is, even still it is relevant. That is, if you get something that is cheaper, we can go an extra mile. Okay, you'll be walking or going there, you'll be getting that. But at the same time, they would go to the nearest well because water was free and heavy to carry. Okay, water was free, of course. It is not about cheapness or something, but it was free, but it was heavy to carry. So people do not, normally we won't go much distance because free water is available here and you have to carry it. It is heavy when you carry that in buckets or other pots. Now, Snow could see that, Dr. John Snow could see that the fatalities clustered largely among those who lived near the Broad Street water well, a particular water well called Broad Street water well. So he identified that much of the people who died of cholera were that is getting water from, drawing water from this particular well, Broad Street water well. Then he and his students took the handle of the water pump. That is, people were getting that, that is a borewell like thing. That is, you can pump the well and get the water out. So they removed the handle of the water pump. Okay, and new cholera cases dropped rapidly. So with that, that is, when they disconnected the supply of water from that well by removing the handle of that borewell, the cholera cases started dropping rapidly. Okay. So by disabling the pump, Snow demonstrated the spatial relationship between cholera fatalities and the Broad Street water well. Okay, see this? This is the spatial connection. Okay, which is the point of origin of the cholera or the spread of cholera that was identified, and then they cut the water. supply from that particular well. Okay, more importantly, he established the relationship between cholera and drinking water. That is also there. At that time, people were not much aware of all this, how a particular disease is being spread, like that. Okay, so at this time, this was also clearly mentioned, clearly done or clearly shown by Dr. Snow. So that is the Snow's mapping or the first GIS or the manual GIS experience, and you can think of that. It was in year 1840. Okay, so that is a manual GIS. Now, coming to exactly what is GIS. Having said all this, it's a computer-based system and all this. So as I told you, GIS is Geographic Information System, no doubt in that. In practical terms, a GIS is a set of computer tools that allows people to work with the data, that is tied to a particular location on the earth. That is data, of course, fine, but that data is tied to a particular location on the earth. Okay. A GIS is a database that is designed to work with map data. You can think of like that also. It is a set of computer tools that allows people to work with data that are tied to locations or a particular location on the earth. At the same time, a GIS can be considered as a database that is designed to work with map data. That is another thing. Now an example is shown. That is, think of a company, a telephone company like or BSNL or Airtel or whatever be that. Okay, they maintain a large computer database, especially the accounting department. Database of their customers in which they store the name, address, phone number, type of service, say postpaid, prepaid, or broadband, or FTTH, different types of services they provide, and billing information for each customer. So, what is my amount? What is the bill amount for me? So, they have to send the letter, I mean, the bill to me. So this information is only incidentally tied to where customers live. Okay, it is not their business. That is where you are staying. But one thing is sure: if you are staying under the jurisdiction of this particular company, you are bound to pay the bill what they give. They can carry out most of the important functions without needing to know where each house is. Okay, they can. That is, the accounting department doesn't need to know where this particular house is. But what they have to do, they have to identify the customer. What is his customer ID? Okay, what is the bill for last month or this month? They have to send that. Okay, for sending the bill, the accounting department doesn't need to know where this particular house is located. Okay, but they need to have the addresses for mailing bills, but it is the post office, because most of the time now emails have come. Earlier that they used to send it by hard copies. So the post office people, they should know when they are sending an address. So the post office people should know where this particular location is or where this address is there. Okay, where the house actually are or where the office actually is. So, okay, this type of information, that is the data or the information that is done or worked with or being carried out by these people, that is the accounting department, is called as spatial data, a spatial data. As spatial means it is not spatial like that, meaning that it is not tied or is only incidentally tied to a location on the Earth's surface. That means you need not bother about the particular location on the Earth's surface where this location is, okay, or where this data is tied to. That without that location, without that information, the data is there. That is called as spatial data. Whereas the real people on the service department, that is, we say the lineman, the overseer, or engineer, or whatever be the different names that we call, the employees of the service department, however, need to work with the spatial data to provide the telephone services, because from the office they will be given, okay, this particular phone number. So they have to go, which is the address, okay, where exactly, on which road, on the left or right of that road, which house, what is the house number, in which village, which panchayat, like that, everything, the in their location they should know. Then only they can go there and get the things done. If there's a complaint from a particular location, particular house, particular connection number, so they have to rectify that. Okay, so that is called, that particular information what the service people are depending upon or they are working with is called spatial data. Okay, now for example, when hundreds of people call in after a power outage, the service department must analyze the distribution of the calls and isolate the location where the outage occurred. Okay, so a problem has occurred and many people will be calling, okay, I'm not getting, my telephone is out of order. So many calls they may come. Okay, maybe they're calling from their mobiles or something like that, but they have to identify which location, in which area this particular service outage has happened. Okay, so again for that they should know which is this particular location. So that is spatial data. So in this example, we have seen two types of data or two types of softwares are required. One is for the accounting department, they uses special software called a database management system or DBMS, or which is optimized to work with large volumes of spatial data. That is the information, that is their name, their scheme, what is their bill, what is the due date, like that. That's that kind of part, that is the spatial data. Whereas the service department needs access to a database that is optimized for working with the spatial data, a geographic information system. Now you think of a map that is available to that particular company service sector. They will be showing that, for example, where our college is situated, Pannani municipality. If they are having the map of a Pannani municipality with all the houses located, house number, offices, everything marked. So with that, if somebody is sent from the service department, they can easily go there and come back. Now the advanced version of this part is what we see in the Google Map and all. Okay, the services which are available in our map, in our mobile, and the same spatial data is what you share. And you say that I'm going to my friend's house, and maybe a third friend maybe also be coming. So you will say that, okay, I will go there once, then I will share my location. So what do you do actually? You are sharing a spatial data. Okay, the spatial data of your friend's house location. Okay, that is what we do actually. So now things have been easier because the GIS is in action. Now coming to the components of GIS. So what are all the components of GIS? Major components are, the first one is the GIS software or GIS application. Then the hardware. And the hardware is capable of data storage, data input hardware, information output hardware, like that. So the hardware, there will be three parts for data storage, data input, information output hardware. GIS data, that is the third. The next one is GIS data. The second component is, the third component is GIS data, and next is GIS personnel and procedures. Okay. So these are all the components of GIS. Okay. These are the components of GIS. You can see the hardware, software, people, data, methods. These are all the components. And it is an elaborated view of the previous picture, which is showing the maps. That is how the GIS can be defined. The analysis part, data, software, the satellites which are providing the data, then the carriers or the person who are working with that, then the apps. And coming to the hardware component, what are all the hardware components? We can think of the computer, the CPU of the computer, the monitor, the CD-ROMs, which we rarely use now, the scanner, digitizer, and this is the digitizer was earlier used. Now we are doing everything online, on screen only. So that is a digitizer, and then the output devices like plotter or printer for large maps. Small printer will not be enough, so we call we use the plotter, another instrument. So these are all, what are all the hardware, and now we have the network of computers, the web-based computers. So in some systems, in some terminology, we say that there are 6 components for any GIS. So we bring in the network component as well, or sometimes we bring that as a part of hardware because all the networks are also part of hardware, like that. Then the GIS software. When you talk about software, again, we have different types of software. We have the proprietary or licensed or commercial software. At the same time, we have the open source software, and sometimes we have the free software also. And all open source software may be normally free, And but all free softwares need not be open source. Open source means they are providing the key. I mean, they are providing the source code of the software as such. So if you want to customize that, you can use that. And in the case of a GIS software, there will be, earlier we had seen the different modules that must be there. So pre-processing of unstructured geospatial data will be done by the software. Integration and transmission of geospatial data will be done. That is also done by the software. Analysis on the geospatial data will be carried out. Then releasing the manipulation of data with the help of graphical user interface or the GUI will be done. Then performing quality checks, standards, and testing on the manipulated data will also be done by this. Releasing the updated final product to the end user. That is, it can be in the form of a map, sometimes it may be a chart, sometimes it may be a diagram, everything that will be there in the form of an output. That is also the duty of a GIS software. Okay, so this is GIS software. And coming to the data, so what are all the data sets? Normally, we have already told that we are dealing with the spatial database. So you think of the real world on the left-hand side. So we are bringing that into different layers. Okay, survey control points, water feature, water bodies are separated out, boundaries, then addresses, transportation networks, roads, railways, and all. Then the elevation data will be there. Then the satellite imagery, which is showing an bird's eye view of the entire area. So this is the real world, and this is the GIS world model. In GIS world model, we have got layers of data one over the other. So data sets, the different data sets will be working can be considered as different layers of data. Is yet another example, that is the real world data will be brought in by combining the street data, the buildings data, the vegetation data, and when we integrate all those together, we are getting the real world data. So these are all different data sets. Then different people are working on that, starting from the GIS data entry operator, the teachers, academicians, researchers, students, then the army people. In this picture, we are seeing certain defense people, certain army people who are working with the maps or the GIS system. Then exclusive GIS personnel, engineers, and GIS experts who will be working with the satellite imageries and other GIS CAD and all other related technology will be there. Then different people who are working can be classified or classed into different part. I mean, image processing experts who will be experts in satellite image data interpretation, image processing. Then there will be people who are developing the GIS softwares, and there will be certain people who will be experts in analyzing the GIS data. And there will be project managers who will be exclusively doing GIS projects, and they'll be handling a lot of people, a lot of data, and they'll be giving solutions to different people as by conducting projects. And this is a workflow or the GIS workflow or the GIS process. Normally, what happens? First, we may be defining a problem, then the GIS data criteria. So, what type of data we need? What is the scale of the maps? What type of attribute data we need? How do we want the latitude, longitude data sets like that? Then they will be bringing that into build data sets. Then in the next step, GIS analysis will be carried out. Then an output will be there. Based on the output, a decision will be made. For example, if you want to know when you are widening a road, which are all the land parcels that is going to be affected, who are all the people who may be needed to give the compensation. So all these things may be carried out, and a final map will be produced. That is the output, and together with that output, we will be having a table as well. So these are all the people who will be affected, whose areas at what particular acre from this particular person. So what is the land value at that particular area? So how much compensation need to be paid? So based on that, the decision will be taken. So that is how a geographic information system GIS workflow will be progressing. And normally the GIS functions, we have seen that the sub-functions, the data entry should be done. So a good GIS software must be capable of doing the data entry. Then data management might be there. Then thematic mapping, that must be there. Then data analysis. Thematic mapping means individual. Each layer is a particular theme. Okay, we have seen the boundary is a layer, road network is another layer, then the vegetation is another layer, like that. So each one is a theme. So separate layer-wise maps can be done. Then the data analysis and the map layout. So okay, different functions are there that is to be carried out by a GIS. Okay, these are the basic things: data entry, data management, thematic mapping, data analysis, map layout, and the retrieval and editing that will come in the thematic mapping module. Now, what are all the questions that normally a GIS can answer? These are all the questions. One is, what is at? Okay, if you want to know, what is at this particular location on the, say we say, there's a stream, a rivulet that is joining to the main river. So at that particular point, which is that big building that we see normally in the satellite images and all. So what is at? Okay, simply by looking through the database, latitude, longitude, okay, this particular location is asked. So what is at that particular location? Or by the street, this corner, this junction, this road, meeting points, any query you can add, that question can be answered by the GIS. Then another thing is, where is it? Okay, you're asking, okay, where is the best hotel that will be giving you a non-vegetarian food? Okay, so you're asking the system, and the system will go through all the database. It will show you, okay. And if you want to get the radius, say within a reach of, say, 200 meters from where I'm standing now. So if you are asking the system is telling you, okay, this is the way, I mean, this is where. Okay. Then another thing is what has changed since. An easy example that you will understand is, suppose if you want to analyze what has happened to our coastlines. We say about sea erosion, whenever large monsoon comes or whenever the large wind comes, we have the coastal erosion, okay, the wave attacks. So how far our coastline has changed, say since 2000 or since 1990? What type of changes have taken place? So that change we can easily understood by this GIS. Okay. Then another thing is what spatial patterns exist. That is there any relationship between the topography of a region and the rainfall that is received by this area? So is there any particular spatial pattern that is there so that you can understand? Then, what geographic variations exist over space, as we had discussed earlier? That is that is when you go from say Pennine to Palakkad, how the geographic variations are there. Whether you are leaving the coastline, you are moving through the midlands, and you are slowly reaching to the highlands. Of course, Palakkad region is there's a gap, of course, but if you go on the left or right of Palakkad gap, you have the highlands or the ranges. Okay, and the last question is the kind of modeling or simulations. That is, if conditions are going like this, what will be the situation? For example, if you want to model, if you want to simulate, if you want to know that in the computer itself, how that is, if the sea surface temperature is increasing like this, or the global warming is increasing like this, if sea level is increasing at a rate of say 1 millimeter per year, at what particular point of time the coastal towns of India will be underwater, they will be submerged. So what are all the threats that we have to foresee? So like that. So what if the conditions are going like that? Or if the water levels are declining like this, so will there be a shortage of water after a few years? So the conditions, okay, that kind of modeling using spatial data that can also be answered by a geographic information system. Okay, so far we have seen GIS. What is GIS? What are its different definitions, and then the components and the questions that can be answered by a GIS. Okay, so in the next session, we will be talking about maps and its scales, its types. Okay, so please stay tuned for the next lecture. Thank you for watching. Thank you so much.